Next, we continue with the next subtopic, that is independent events. So, if A and B are independent events, the probability of event A has no effect on the probability of event B. Example of independent events. Let A be the event of getting the result of flipping a fair coin, and B be the event the number obtained when a pair of dice are rolled. So these two events are unrelated, as obtaining a head on the coin will not influence the outcome of the dice. So any event that involves with replacement is also an example of independent event. So if event A and B are independent, the occurrence of event A does not affect the probability of the occurrence of event B. Then probability A given B will be equals to probability A, or probability B given A will equals to probability B. So for conditional rule, your probability A given B equals to probability A and B over probability B. Okay, since probability A given B is equals to probability A, then your probability A given B will become your probability A only, and equals to probability A and B over probability B. So therefore, you cross multiply it, your probability A and B equals to probability A multiply with probability B. So in conclusion, if A and B are independent event, your probability A given B is equals to probability A, or probability B given A is equals to probability B, then your probability A intercept B is equals to probability A multiply with probability B. Probability A complement intercept B complement is equals to probability A complement multiply with probability B complement. Probability A intercept B complement is equals to probability A multiply with probability B complement, and probability A complement intercept B is equals to probability A complement multiply with probability B. So for example 1, this is your example 1, try it yourself later. So example 2, A, B, and C are three events, okay, such that A and B are independent, whereas A and C are mutually exclusive. So the solution, so A and B are independent and A and C are mutually exclusive. And this is the information that you are given from the question. Your probability A, probability B, probability C, and probability B and C. So find A, your probability A union B. So from the formula, probability A plus probability B minus probability A intercept B. So substitute the value of your probability A 0.4, probability B plus 0.2, and the value of probability A intercept B. Okay, because we know that A and B are independent event, so then the probability A intercept B is equals to probability A multiply with probability B. So therefore, probability A multiply probability B. So 0.4 plus 0.2 will be equals to 0.6 minus probability A is 0.4 multiply with 0.2, your probability B. So 0.6 minus 0.08, calculate it, you will get 0.52 for probability A union B. So next, find B probability C given B. Okay, so use conditional probability formula. We know that equals to probability C intercept B over probability B. So know that probability C intercept B is equals to probability B intercept C. So that is equals to 0.1. So substitute the value there. So then probability B, substitute the value 0.2, you will get 0.5. Okay, we know that the relationship of A and B are independent and A and C are mutually exclusive. So let's check the relationship of B and C. So because we know that probability B intercept C is equals to 0.1, so that is not equals to 0. Therefore, B and C is not mutually exclusive. Then check for probability B multiplied with probability C. So we have probability B that is 0.2. So probability C that is 0.3. So multiply it. So you will get a value of 0.06. So found that probability B multiplied with probability C, you get 0.06 is not equals to your value of probability B intercept C, that is 0.1. Then B and C is not independent. So next, find C probability C given A complement. So use conditional probability formula. Probability C intercept A complement over probability A complement. So previously from example 1B solution, we have probability A intercept B complement equals to probability A minus probability A intercept B. Okay, then your probability C intercept A complement will become probability C minus probability C intercept A. So probability C is 0.3 minus probability C and A is mutually exclusive event. It means that there is no intersection. So no intersection, therefore probability C and A is equals to 0. Okay, so 0. So here you will get 0.3 as your probability C intercept A complement. Okay, so substitute the value over there, and then find probability A complement. So here you have probability A equals to 0.4. Then probability A complement is equals to 1 minus probability A. So 1 minus 0.4, you will get 0.6. Substitute it inside there, simplify it, you will get 0.5. Okay, we go to example 3. A mathematics puzzle is given to 3 students, Munir, Mazlan, and Marlini. From the past experience, known that the probability Munir, Mazlan, and Marlini will get the correct solutions are 0.65, 0.6, and 0.55 respectively. If 3 of them attempt to solve the puzzle without consulting each other, find the probability that A, the puzzle will be solved correctly by all of them, B, only one of them will get the correct solution. So information obtained from the statement, we have first is 3 students, Munir, Mazlan, and Marlini. So we let A to be the event, Munir answer correctly, B, Mazlan answer correctly, C, Marlini answer correctly. And the second information is that probability Munir, Mazlan, and Marlini get correct solution are 0.65, 0.6, and 0.55 respectively. It means that probability A is equals to 0.65, probability B is equals to 0.6, and probability C is equals to 0.55. And the third information is attempt to solve the puzzle without consulting each other. It means that the 3 events are independent to each other. So, solution, this is the information obtained from the statement. The 3 events are independent to each other means probability A intercept B is equals to probability A multiplied with probability B. So that is for independent event. So the question, find the probability that A, the puzzle will be solved correctly by all of them. It means that probability the puzzle will be solved correctly by all of them equals to probability Munir, Mazlan and Merlini answered correctly. That is equals to probability A intercept B intercept C. Because the events are independent, therefore equals to probability A multiplied with probability B multiplied with probability C, where you have their probability A is equals to 0.65, probability B is 0.6, and probability C is 0.55. Multiply it, you will get 0.2145. Okay, next, again, this is the information, and the question is, find the probability that only one of them will get the correct solution. So, probability only one of them will get the correct solution have three situation or case. That is, only Munir A answered correctly, Mazlan and Merlini answered incorrectly. It means that the event of B complement and C complement. Okay, the first situation. And you will get probability A intercept B complement intercept C complement. And the second situation is that only Mazlan B answered correctly. So Munir and Merlini answered incorrectly will be the event of A complement and C complement. So the probability A complement intercept B intercept C complement. And the third situation is that only Merlini C answered correctly. Therefore, Munir and Mazlan answered incorrectly. Therefore, A complement and B complement. Probability A complement intercept B complement intercept C. So this is the three situation or cases that you have to consider, and this is the probability that you will have to take. Okay, so from that, probability only one of them will get the correct solution is that equals to probability A intercept B complement intercept C complement plus probability A complement intercept B intercept C complement plus probability A complement intercept B complement intercept C. And remember, for tree diagram, add between branches. Okay, so for probability A intercept B complement intercept C complement, because this is an independent event, so you will get probability A multiply with probability B complement multiply with probability C complement, and probability A complement multiply with probability B multiply with probability C complement plus probability A complement multiply with probability B complement multiply with probability C. So the value for probability A from your information is 0.65. Multiply with probability B complement, you have probability B is 0.6. So probability B complement is 1 minus 0.6, you get 0.4. Okay, so multiply. And then you have probability C complement. From your information, you have probability C is equals to 0.55. So probability C complement is 1 minus 0.55, you get 0.45. So there. Plus probability A complement, again from above you have C, probability A is 0.65, so probability A complement is 1 minus 0.65, you get 0.35. So probability B from above is 0.6, multiply it, and then probability C complement from above is 0.45. Okay, plus probability A complement from above is 0.35, multiply with probability B complement from above is 0.4, and then multiply from above probability C is 0.55. Sum it up, you will get 0.2885 for the probability that only one of them will get the correct solution.